Hello, this is my English speaking practice, and I'm working on coding problems. So, from today, I'm going to solve medium level problem, and yeah. So let's go. Maximum product of word length. Wow. Okay. Given a string array words, return the maximum value of length word I, length word j, where the two words do not share common letters. If no such two words exist, return 0. So example 1. In this case, there are two words like ABCW and XTFN. They don't have they don't share common letters, and each words have 4 lengths, so the answer is 16. And this case, AB and CD is the combination that can get the most maximum value of this formula. And in this case, each words have shared letter A, so we should return 0. Okay. And there are constraints. Word length is 1000 at most, and word length, so this length is 1000 at most, and each word length is also 1000 at the most. So so most simple solution is to check all the combination for each words. So there are 1000 words, so the number of combinations be like thousand divided by 2. 1 million, about 1 million. 500,000 technically, right? And I think it's not bad, right? So the time complexity be O of n, n squared, but the n is 1000 at the most, so it's not bad, I think. So let me submit this solution. But I think okay. Let me try. うん。うん。I see the problem. We have to check the common letters. So this takes some time. So it's not n squared. Right? If not, they doesn't. If not, they have common letters. We can calculate the answer. Right. And return answer. The problem is this. This function, maybe it takes this would be like a linear algorithm. So so for the naive implementation, we have to check common letters. Yeah. So A, B, C, D. So I think this is not good. This solution is not good. I can implement this function, but it's not good. It's not the answer. It's not the expected answer. It takes too much time. So yeah, I have to change the strategy. The two words do not share common letters, so I want to sort the words by its length. And we are try to use these words, right? A, B, C, D, F, D, F, length is 6. So might be possibly this is contain this is a part of the answer. And after that we have to look at one by one. A, B, C, D, E, F. So for example, in this case, this one is chosen and this one is chosen as the other words, cause B is shared, F is shared, B is shared, PL is good. So in this case we get 12 as the answer, but we cannot find out this is the maximum, so we have to check the next words. And for this ABCW and XDFN is the answer. At this point we can find out this is the answer because the second words is most longest words. So if the second words is longer than the next first candidate, we don't need to check remaining words, because this is the maximum we can find out. Okay. And but the problem is how to check if they have common letters or not. If we check it one by one, we cannot reduce we can't reduce the computation, reduce the amount of computation. So common letters A, B, C, D, E, A, B, C, D, E, A, B, C. A, B, C, D, E. A, B, C, W. Do not share common letters. I'm not sure. I have no idea. Python sort. And okay. I forgot the syntax. So sort its length, sort its length, sort its length, sort it by its length, and reverse it. We can get this one, and after that I want to loop through this, or before loop it, I want to create something, some data structures in order to check common letters A, B, C, D, E, F. common letters or not, common letters or not. And multiplication, A, B, C, D. Mm. 432, 432. 6 times 432, but 4 not good, 3 not good, 2 good, 4 threes. Bus, who, bar, and 2. A, B, C, D, E, F, A, B, C, D, E, F. So when we check these words, we have to check all of letters A, B, C, D, E, F. A, B, C, D, E, F. How to check it? It cannot be avoided. It cannot be avoided. It's not avoidable. We have to check the letter one by one, right? A, B, C, D, E, F. B, C, D, E, F. So without A, without letter max length, if if this means without A we can get length 4 because there is XDFN which doesn't contain A and its size is 4, right? And for B is as well, C is as well, A, B, C, D, F, G, 6, like that. We can make this kind of data structure, and we check A, B, C, D, E, F one by one. And so this case we have to check A, B, C, D, E, F for each letters, and we can get 4, and we can get 4, we can get 4, and we can get no, we can get 4, but this is not good because we have to find the words that doesn't contain A, B, C, D, E, and F. And we can get 4, we can get 4, we can get 4, and we can get 4 A, B, C, D, E, F. So it looks like we can get the word that length 4, right? But actually we cannot get length 4 because this A, B, C, these parts comes from this one, so we can use these words for this part. But this part we can get 4, but this comes from this one. So when we check these words, it seems we can get 4, but it's not actually. We have to check it where it comes from. We have to check where it comes from, right? A, B, C, D, F, G. Yeah. So it's complicated. To think it in different way, let's find out the common letters. Common letters. Hmm? No. Zero, ich, san, 0, 1, 3, 5. Zero, 1, 3, 5. So 2, 4, 6. We can make. Hmm. No. No. Common letters. Let me think. The word length is 1000 at most, but the words consists only of lower English letters, so there are 26 at the most. So we have to look at the letters one by one, but it's at the most 26, so it's in constant time. 26, because if the words has more than 26 characters, they must be no, they can be they maybe use only one kind of letter. So first, so for example, if the length is 1000, should be it should contain the letters, the kind of letters that appears in the words. So this case, the word length is 1000, but the letter that appears in the word is just A, B, C, and F. In this case, in this example. So thanks to this, we can reduce the computation for checking, because there are only 26 kinds at the most. So in this case, we just loop over A, B, C, F, and we have to look at this one. It have A, F, A, F, A. This word doesn't have A, B, C, F, so 2000 is possible answer. And next we check A, B, C, D, E, F. A, B, C, D. Let me code it. how to convert it. And for I in range, this is same, but we can reduce this. We can reduce the computation, this part. If not common letter A and B. Yeah, cause was I and was J, A B A B A B A B. So this function takes A and B and it can use kinds. No, it's index I and G. J takes index and kinds A. At most 26, right? At most 26. If B, if the letter in B return false, no, return true, return false. Okay. This function returns in constant time, right? So, yep. A and J, the word words. That's it. Let me see. Word is not defined. Was. Maybe we don't need to sort. What? Index out of range. Index out of range. Ah. Kinds append kind. Cannot access local variable ans. Okay. Correct. So this can be executed in constant time, so that total time complexity is n squared. This loop contributed it. Let's go. Not bad, but it's not volume zone. Let me this one. Bit mask. What is it? Only 26 possible letters, so I can get the hint. I can get the key information, but it's different how it's solved. Form a bit mask for each word. Then bit mask frequently pick the two highest dict values. Get the bit mask is a function. It takes a word and I cannot understand. But it shifts the bit based on the character. Get bit mask and default dict int words word. Get bit mask. I see. Bit mask. I see. Bit mask. So this function converts the word into the bit mask, and the bit mask is used as the key of this dictionary, max length by bit mask. And this dictionary's value is the length, its length. And how to find the answer? Product bitmask and bitmask 2. So this is same as double loop, because it's a product. It just finds a product. And yeah. Yeah, if the bit mask is the same, it has a common letter, so continue it, not continue, continue the loop. We cannot move forward. And if the bit mask is 0, which means they doesn't have a common letter, so we can update the answer like this. So yeah, essentially same. The difference is just to use set or bit mask, right? So yeah. So let me use bitmask, because bitmask is more efficient in memory, in the from the perspective of memory. So I'm gonna change the code. So this part we can change. So function get bit mask is, it takes string and returns integer. The bit mask but it's difficult to implement it. So ask AI in Python how to convert string bit mask representation. This one. Mask is 0 at first and loop over the string and takes the bit and shift the bit and update the mask. This is a bit mask. And length is default dict. and update the length. Word in words and length and get bit mask the word of the word. Like this, right? Yeah. And has common letter, not has common letter, means oh wait, I see. Okay. Choose two entries from the dict from a dict. All combinations. Combination can be used. Can I use this? Permutation, combination. I'm not sure, but let me try. Yeah. We can get a pair and this must be pair. How to A and B. So yeah. So A is the key. A is the key. B is the key. So if A0 and B0 is 0, continue. This is not defined. D is not defined. Okay. Yeah, let me see the result. What? What is the difference? Ah, I see. Yeah, I think so. Mask. Get bit mask. Word. All ordered pairs. This one is good. This is redundant because it contains same pairs. And comparison chain and precedence can bite. Safer is. Okay. Not 0. But only shows from collection input implicitly. Assuming inputs are fine, ignore this. The critical part is here. We have to check. We have to check if its length is the maximum one or not. Great. Beats 95%. Okay, so yeah, so I'm gonna finish this problem, but I want to improve my English, so let me review this problem. maximum product of word lengths. Given a string array words, return the maximum value of length words I times length words j. Where the two words do not share common letters, if no such two words exist, return 0. So, for example, in this case, there are 1, 2, 3, 4, 5, 6 words, and the answer is 16 because ABCW and XTFN is the combination that can make an answer, that can meet condition. That is, the two words do not share common letters and the formula can get the maximum value. 4 times 4. The answer is 16. A, B, C, D, E, F. This length is 6, so this is the first candidate, but there is no words such that there is no words that doesn't contain A, B, C, D, E, F. Each word contains A or B or C or D or E or F at least. So the answer is this combination. And so basically we have to loop through each pairs. So this I use this function from iterator to combination function. It takes iteration, and we can specify the element numbers. So in this case, we can find we can iterate through all of pairs, all of combinations. So this takes n squared time complexity, right? N times n minus 1. The number of combination is n times n minus 1 divided by 2. So the time complexity of this part is n squared, and the main problem is how to check this condition. The two words do not share common letters, so the length is 1000. Word length is 1000 at most. So in the naive solution, it takes linear algorithm. So overall, it might take n cubed. So it's not good. So we have to reduce the time complexity, but basically we cannot reduce this part, right? Basically we have to check all of combinations. So we have to improve. We had to improve this part, and I found the fact the words consist only of lower English letters, so there are 26 kinds of characters, so we can reduce the time complexity thanks to this. So when we check the condition, the two words do not share common letters, we have to look the letters one by one, basically. And it might be 1000, but there are 24 kind of characters, so we can reduce it. And the first idea that comes to my mind is to use set structure. So I So I prepare the list of set, and each words convert it into the set like this. And this part is the for combination, and this function check if they have the same common letter or not. And the set length is 26 at the most, so we can check it in the constant time, right? So overall, this part is executed in n squared time complexity. So this is the valid answer, but it's not fast and not efficient in perspective of memory, right? Okay. And this is the improved version. Essentially it's same, but I used bit mask instead of set. So bit mask is integer, so it can be used as the key of dictionary. So this function is just converting the string into the integer bit mask, and this part is preparation for this part. We prepared default dict, and each word is converted into bit mask, and we have to store the maximum length by for each bit mask, right? And after that, this is a real part, and this is the combinations. We iterate through all of combinations of this dictionary, and this is the check. This is a check of the conditions. If this calculation is not 0, it means any of bit is matched, and it contributes to the result. It contributes that the result is greater than 0. It's not 0, and it means they have common letters, right? Because each letter has a corresponding bit, and if they are not 0, they have common letter, right? And if not, we can calculate the multiplication and update the answer. That's it. Thank you for watching. Bye.